to the 90s and today to the 20s. That today there is an accountability. So the same thing is happening in AI space. Today we have got FSB, which is nothing but the financial stability boards when it comes to the financial institutions, the financial industry, where there's another group called the ethics guidelines for trustworthiness of AI. These things are quickly coming into place, and these are international, kind of people who give a guideline and try to bring some sense, and it'll take some time before it settles down and we get some. It may not become law right now, but that day is not too far off, and these kind of requirements will fall in place. So while AI has now become mandatory, what happened to COVID? COVID gave a big boost to AI. So it was able to, and it all shifted onto the cloud and delivered down the mobiles, and we were there happy at home, teaching or doing whatever we had to do. And so today, because it has come to stay, because it has reached that level of maturity, the next important one that's crucial today, AI. Now you have some numbers on your screen in front of you. These are typically, if you look at the majors, the major IT vendors, the giants of today, they have got years, and in these years and the decade of experience, they have got so many client engagements. Each client engagement has something to be learned from across multiple industries and across a global footprint. These statistics that you have here obviously belongs to IBM. They have done over 40,000 of these customer engagements. So that is a wealth of experience that is being brought to the table across a very wide range of industries and so many countries. So that brings us to the topic of AI ethics. And then when we look at the ethics of it, there are five main pillars, if you like: transparency, explainability. Am I able to, really be open? I need to declare where my data is coming from. Today, data is all over the place, and when you bring that together, how transparent am I? Am I on that? Where did I get it? What is the source of it? What is the lineage of it? Okay, am I able to explain what is the rule and what is the criteria with which I do it? Is my whole build of the models, for instance, with fairness. If I'm doing, let's say, if I'm deploying AI in a human resources part of a company to let's say to hire some people, to what extent would it be fair? Is there a bias that is coming inside there? Am I favoring a particular ethnic group? Is there some profiling going on silently? If you go out there into the net and search, there are a lot of instances of how very famous names that we are so familiar with that had to drop entire models. Okay, robustness of the privacy of it. So these are aspects, these five pillars which govern TAN AI is what now I'm going to hand over to Rachana. And I'm sorry I took away 2 minutes of her time, but I'm going to quickly hand over the session to her. She'll take you into a deeper dive on what and how IBM builds this very robust next generation AI, cognitive AI enterprise, one which understands and the languages of the models, and which is able to produce a kind of automation at the same time maintaining, increasing the trust levels steadily and consistently. So over to you, Rachana.
Thank you. Thanks, Lawrence. I'm sharing my screen. Just tell me if you're able to see it. Can you see my screen?
Yes.
Okay. A very good afternoon, everyone. It's very nice to see the participation. And before getting started, for those of us celebrating Mahashivratri today, a very happy Mahashivratri. And I'll start with this topic. I think over the multiple sessions on AI, data, and things like that, I'm sure you've heard about the usual topics like what is supervised learning, unsupervised, reinforcement, what are the open source packages that are available, how are enterprises building it, etc. But this talk, we are going to talk about how enterprises are adopting. So even though AI models exist, the models must be governed. They can't directly be taken and used in any of our projects if they are not properly governed. So why is that is what this talk is going to be about. So before getting started, let me just say this one thing. If in our day to day life, when we are doing certain things, we are naturally inclined towards giving some people certain partiality, isn't it? And it's faculty that we're talking to, so I don't know how many times we got these complaints from our students saying this so and so faculty is partial to so and so student. So it happens. So we are naturally tuned that way. Human brain is naturally tuned that way. So depending on the conditions that we see, if we find a promising candidate, we are naturally hardwired to exhibit some bias or some partiality to these candidates. And with AI, we are training machines to think like humans, and hence AI models are also prone to this particular behavior where AI models also start exhibiting bias to some of the individuals. So these individuals can be anything. So if you have a banking model which is determining who gets a loan, who gets a certain amount of loan. So we've seen AI models exhibiting bias to female candidates. So this particular AI model is, if the gender that is identified is female, it is naturally showing high affinity to give this candidate with a loan. And similarly, other cases in US and other regions, AI models are exhibiting bias to certain ethnicity, certain candidates with certain ethnicity. So maybe African American people are experiencing bias from AI models. So when enterprises are creating AI models, if these kind of biases are in the models, we cannot use it. And forget using it, we will be fined with so many standards. So how data governance and GDPR exist for data residency. Similarly, for AI models, there are standards and legal standards that organizations have to follow before putting them in production and to use. So, this particular talk that we are giving is primarily going to talk about how to identify this bias in models, how to mitigate the bias, how to make our models explainable. So, if you see this particular slide, these are the rising concerns over trust, and these are several open articles that are on web. So if you see, even Apple is the most, Apple is in FANG. That's like the dream company for a lot of us to go work for. But even Apple got fined. Apple faced serious legal charges because their AI models were biased towards certain categories and their AI models were unexplainable. So why this model is taking certain decision was not, they are unable to provide that particular explanation, and hence they got sued. And similarly, there are a lot of such incidents. So one such interesting incident I'm going to tell you. So recently we were in conversation with a ride sharing company in US, and this ride sharing company has a lot of machine learning models deployed and being consumed. So take Uber for example. So what Uber does, when two people are requesting a ride from ride, the driver does not get an option to pick who gets the ride. So the algorithm itself sets who gets the ride. So this particular ride sharing company, right? So they had a AI model which was saying who will get the particular ride. So this model, to the architects who were working on this particular project, they were very smart. What they said was, these sensitive features where we are experiencing bias and fairness issues, I will remove those features from model training altogether. So these features like age, gender, ethnicity, they removed these features altogether from the training data set. So the model was not disclosed with data like gender and ethnicity. Also, when they put the model in production, the model started exhibiting bias towards certain ethnicity people. So African American people were experiencing, the cab drivers were not getting an option to select those rights because this AI model was picking them, putting them in a lower category. So why did this happen? Even though they did not disclose the features, what happened in the backend was, even though the model was not disclosed with features like age, gender, and ethnicity, the model was disclosed with things like zip codes, area codes, the crime rates in that particular areas, just to have driver safety. So if a driver is getting a request from two areas, the driver will get an option to go into area where the crime rate is less. So that's how the model was trained. But what happened was the crime rates in US are indirectly correlated to ethnicities, and the model started exhibiting bias to ethnicities. And when these incidents happen, ultimately the enterprises start getting sued by a lot of law firms, and there are boards as well. So this particular slide just explains those incidents. These incidents are happening. AI adoption, it's no longer about AI adoption. AI is there, enterprises are using it, but the problem is trust. How will we build trust into our models? And one more such example is ChatGPT. ChatGPT was is in the news heavily right now, but not a single enterprise is picking it up and putting it in their enterprise organization grade solutions. It's primarily because it's an open project. There are a lot of explainability and trust questions that are coming up, and hence ChatGPT is still under, it's an open project. It's a project by OpenAI, and hence it's not an enterprise grade solution. So unless all these things are being, unless all these concerns are being addressed, we really won't be able to, put our AI models into production where we are saying hundreds of people can start consuming it. So these are why worry about AI and compliance. This is why. So recently we've had an incident with a very leading bank who were fined with 175 million for charging higher fees and interest rate to more than 30,000 minority borrowers. And these are some of the AI boards which are in existence in the financial industry. But similarly, for every industry, there are such standards, there are such compliance standards who are actively monitoring AI models and actively governing AI models. And if your AI model is not compliant to one of these standards, banks and every industry for that matter are facing serious legal issues. So that is like an overview of why do we have to uh, embed trust into the whole life cycle. um, and now I'm going to talk about how do we do that, what are the algorithms that are available, how do we, once our model is deployed, what should be done, how do we actively govern it, are there any alerts that we can set every time this goes off. So we are going to talk about, now we'll get into the technical side of it, how to implement it. So if you look at a model development life cycle right now, this is typically how it's happening. So there's model proposal, where our senior business leaders are going to set business outcomes and KPIs that they want to drive with by using this certain AI models and ML models in a certain project. Let's say a loan application, right? So this is a very popular use case that a lot of us must have worked on, where you have a whole data set of loan applicants. You get their age, credit history, previous any properties owned, what was the previous loan structure like, all these things. So when you have these details, depending on the pattern, you can determine for the future users if giving out a loan is risky or not. So that goes into model proposal. Model proposal is a phase where you define the outcome of this particular project, how AI will be used in the following use case. And then comes model development and unit tests. So model development is where you get the data set and you split the data set into training data and testing data, and you train AI models and ML models depending on the project that you're working on. For example, if you take this particular use case where you're predicting giving a loan to a certain applicant is risky or not, it's a classical classification problem, right? So you will probably go for a classification ML model. We train this ML model with training data, the 80% or 50% split that we take. We train the model on that, and then we perform a quick testing. So for the model that is trained, the other split, the 20% of the data that you got, you test the model and understand the accuracy of the model. But imagine if you have 1,000 records of data. Out of 1,000 records of data, if you have 700 or 800 records where the gender of the person is male, right? So out of 1,000 data points, 80 data points are for males only. So when you train your model, when you train your classification model, it will automatically start exhibiting bias towards every time it encounters a male. Since larger amounts of data that the model is trained are male records, it will automatically start exhibiting a little favor towards male applicants. Similarly, in the data set, if you have more applicants who are at the age of 30 to 40, the other age groups will start. So if you have so many data points defined for certain ethnicity, that particular ethnicity category will be favored by the model. So similarly, when you're developing a model, when this is a very simple use case that we took of a loan applicant where you hardly have 20, 30 features. But if you consider an enterprise grade model, there are at least 500, 600 training features that we take into consideration. And for each of the training feature, it will be very difficult to understand how fair the data is. So model development, even though we are doing development, the problem is we may not be able to understand how many records of what data is available. And then a pre-implementation review is done. Once the pre-implementation review is done, a pre-deployment validation is done in enterprises. Once these approvals are done, model is approved. Once the model is approved, we go ahead and put the model in production. And that is where we start seeing different kinds of data. Even though the model is trained on certain kinds of data records, once you put in production, it starts encountering different other use cases. And that is where we understand if the model is biased, if the model is exhibiting a favor to certain transactions, if the model is explainable or not, all these things. So it is never easy to understand or plan for all the challenges that might come once the model is in production. So before putting the model in production, if we want to embed trust, if we want to identify and mitigate bias, if we want explainability to be in our model, these are these are the four things that we have to do. Starting with drift, bias, explainability, missing validation, and test data. So starting with drift. Drift is nothing but what is the data drift? So model is trained for 800 male records and 200 female records. But once you put it in production, it will encounter the opposite, right? 800 female and probably 200 male. So what is the data drift that the model is encountering? So that we can avoid this drift and accordingly plan. And second, bias. Bias is where it is very difficult to avoid bias, right? So we never know. We train the model, we get good accuracy because we are only planning for certain kind of data. So we need to make sure that the training data is cleaned from bias. I'll talk about how to mitigate bias in the next slides. And similarly, explainability. So if you remember Lawrence's slides, so imagine a chips bag. So you go to supermarket, buy a packet of Lays or Kurkure or anything. Once you go back, once if you switch the packet backwards, so there is this clear nutrition facts that you're getting. So nutrition facts is where FDA mandated that all these food items should specify how much percentage of carbohydrates are there, what is fat content, what is nutrition content. So the entire nutrition content is available on your chips packet. Similarly, in enterprises, before I put my AI model into use, in use, before I go ahead and deploy, I have to produce a fact sheet, which is as small as a chips packet, by the way. I have, like how they are producing nutrition facts, I have to produce a fact sheet which is going to say, this is my AI model, these are the checks I've done, these are the models that it's using, this is the amount of data it's trained on, all these things. So that is explainability. So once you put your models in production, if someone comes to you and say, why is this decision taken by the AI model, if my loan applicant comes back to me and say, explain the transaction, explain the decision, so the model management should be able to explain it. And finally, missing validation and test data. It's nothing but while architecting the model itself, when you're defining the data features and the kind of data that goes into training, make sure you're not missing out on basic best practices. Something like, if you're training a model on 800 male records, include 800 female records also, things like that. So we have to make sure that the data is consistent across all the features, and then only train our models. So this is a typical enterprise model development lifecycle. So before uh, we will develop it, we use all sorts of supervised, unsupervised, reinforcement, whatever learning techniques we have, we implement it. But getting into a phase where it's consumed by an actual application is what it's what makes the model what it is, and it's very difficult to actually get it done as well. So with all the regulations for that matter. So this is how these are some of the best practices in which it can be done. So I was talking about this use case, right? So let's consider you have a lot of loan applicants from whom we have collected data like age, credit history, previous loans, if the loan applicant is owning a property, gender, address, so and so. And based on these features, they're training a classification model and saying yes or no. So once this model is trained, right, once you put it in production, what what organizations or enterprises are doing is they're training a risk model. This risk model is going to look for these features: drift, bias, explainability, and missing data validation. And this will identify if this model has any bias or not, and accordingly keep updating the transactions. So how is that happening? So let's say I have a data set of 100 data points, out of which there are 40 female records and 60 male records. And for this 60 male records, 57 have favorable outcomes and 3 have unfavorable outcomes. Favorable in the sense the loan got granted, but in this example. So, and for females, I have 30 favorable and 10 unfavorable. So if you see, the data collection itself was unfair. So 60 male records were taken in the data set and 40 female records. Obviously, if you train a classification model, even though the feature importance for male and female, gender as a property is different, it could come down to a case where it plays a major role. So the way bias is identified is that we switch this particular gender. For all the data records where it's male, we make it female. So if you see, we make it 60 female and 40 male, right? And the minute I make uh, the minute I swap that particular feature, right? I just make female to male. You see there is a clear drop in the decisions. So when this particular record was 60 male, there were 57 favorable outcomes. But when it became 60 female, I got 55 favorable outcomes. That means 3 transactions got dropped. And that's how I identify bias. Okay, so this is how we are identifying bias. This is an example with 100 data points, so it's very easy to understand it. But if you increase the scale, if any enterprise grade machine learning model, right, it's at least trained on 1 lakh data points. So this is how it's done, and this technique is called perturbation, where we perturb the feature points where we